going to skip over to Neptune.
I ain't gonna lie, I actually looked at what quiz we got next, and we doing asteroids, right?
Yeah, so we're here on Mars, and in between Mars and Jupiter, we've got something known as the asteroid belt. So we are going to go to the biggest asteroid, and it is called Ceres. There we go. Take a little detour there before we get to Jupiter. So we're going to talk about asteroids today. Asteroids are basically big rocks that are out in space. And most of them are in between Mars and Jupiter, as you'll see. Now, asteroids and meteors sometimes get confused. Meteors, we talked about before, they were very small. They were either little pebbles or even dust particles, maybe something an inch or two, or maybe even a little bit bigger across. Asteroids are a whole different animal. These are much larger. If we replaced meteors with asteroids, we'd all be dead right now. So, in the past, people looked at the stars and they noticed that a couple of them, their motion, started to resemble those of the planets. And so what they were seeing is they were seeing some of the larger asteroids out in our solar system, and that's why it's called asteroids. It means star planet. They weren't quite sure what it was. It had a characteristic of one and the other. You can go ahead and write this one down. The whole thing. I'm probably going to have you write down most of these slides because there's really not a lot of words in this slideshow. Yes. Yep, sure was. Yes. I remember when that movie came out. Jeez, that was like the late 90s. That is a good one. They had a... Nice. They had a really smart promotion they did for that. Everywhere you basically looked, they had a countdown to Armageddon. They had just like a clock that was counting down to opening day of the movie. And they were everywhere. They were at like banks and stores and everything. Everybody knew exactly when it was coming out. Oh, yeah, go ahead. So you can see some examples of asteroids in the background there. And I'm going to have you write this one down too. This is what an asteroid is. Yeah, write the whole thing down. So you can see some of the characteristics here in terms of their difference between asteroids and meteoroids. Again, meteoroids are much smaller. Asteroids, by definition, are a few feet to a few hundred miles across. That's much larger, and they would do a lot more damage to Earth than a meteoroid. Because they are so small, most are irregularly shaped. They're not usually a nice circle, although there are a couple that are shaped nice and spherically, as you'll see next here. So this is an example of the largest asteroid in our solar system. It's known as Ceres. We haven't really gotten close to it until only recently. You can see it was kind of basically a big fuzzball. And until 2006 or a little bit later, we got some better definition pictures of it. But this is what it looked like as of that time. Here's what it looked like as of 2006. But since then, we have gotten some better pictures, and that would be something that you see right here. So Ceres, largest asteroid that we know of, can't be seen with the naked eye. It's too small, too far away. Go ahead and write this down. And on the picture here, you can see the little white thing in the middle. Obviously, it's in the middle of a big crater, and this white stuff here is actually pretty important, and you'll see why in our next slide. If Ceres was billions of years old, like it would be in terms of a naturalistic time scale, if everything just was formed by itself over billions of years, you would expect a small world like this to have no geological activity anymore. You'd expect that it was just a cold, dead, inactive world, but that's not what we see. You can write this down too. And that's what the little white spot from the previous slide was. That is water, other volatiles that have erupted on Ceres and have been frozen into the surface. And this isn't just something that we see on this small world. It's the sort of thing that we're going to see on other small worlds as we get further out in the solar system. Not necessarily just on planets, but also on tiny little moons that are going around some of those planets. All of that geological activity should have long since finished if it was millions or billions of years old. 600 miles across, you can write that down. Yes. So you can see how small it is compared with the world and how small it is compared with the moon. 600 miles across roughly corresponds to 2 Wisconsins wide. So it's not all that big, but it would still take you a while to walk around it. This is the orbit that Ceres has, and this is on one of your handouts. You can see that we've got Mars right here. Ceres is in blue. So for the most part, it does orbit pretty much in the same plane as our planets. If you look off to the side and take a side view, you can see it's not exactly in the plane with the rest of the solar system. It is angled slightly, but overall it is still orbiting in the same fashion. Let's talk about the asteroid belt. So the asteroid belt is interesting. You see pictures like this in different science magazines and science textbooks. So on our way to Jupiter, which will be our next stop, we were just at Mars. We had to go through the asteroid belt. And some of these asteroids are in the path of the planets that they're near. Some of them are not. You can write this one down. And so when we're talking about Trojan asteroids, mostly the planet that they're near is the planet Jupiter. There aren't too many asteroids near Mars's orbit. They get a little bit more dense as you get further away from Mars. And when they reach their peak density, they're a little bit closer to Jupiter than Mars, and they fall off after that. But the asteroids that are kind of around the area where Jupiter orbits, but will never actually impact that planet, are known as Trojan asteroids. And you can see just a visual representation of them right here. So this is the orbit that Jupiter, eventually we'll talk about, has. And the asteroids that are in that path that won't impact it are those Trojan asteroids. Now, oftentimes when you see the asteroid belt, a lot of times on TV or in movies or in magazines, it looks something like this. This is not what the asteroid belt looks like. It is not as dense as seen in many artistic pictures. And just to give you an idea of how not dense the asteroid belt actually is, no spacecraft have gone through it and ever actually hit anything. So there's really not as many rocks out there as we're led to believe sometimes. To just kind of visualize it, actually, let me tell you what to write down first. Go and write down not as dense, and then the second bullet point. So just not as dense from the first one, and then write down the second bullet point. Of course, also include the title here. I was trying to find online kind of an average density of the asteroid belt. I couldn't find something that really brought it down to Earth, but one way to try and visualize it might be, instead of looking like this, you would just have one of these rocks every 1,000 miles or something. So it definitely does not look anything like the background of this picture. It does not, in reality, look anything like this. And it sure doesn't look like this either. But this is the sort of thing you will see if someone ever talks about the asteroid belt on TV or in a science fiction movie. One other thing we need to know about the asteroid belt is there are, when you look at them, little gaps in between different parts of this belt. We call those Kirkwood gaps. Write down Kirkwood gaps, and then just something like gaps in the asteroid belt. Kirkwood gaps are gaps in the asteroid belt. And if you're looking down on all these asteroids, this is the sort of thing that you'll see. It looks like they are just packed full in this area, but you have to remember that each of these dots is so much bigger than what it really would be if you were looking down on this. If you were looking down on the asteroid belt, you wouldn't actually be able to see them because they're so small. It's kind of like those pictures where you see all the satellites in orbit around Earth, and it looks like we have all this, just tons of junk going around us. But oftentimes those pictures exaggerate how big those satellites are. It's not like, if you shoot a satellite and it goes through all this without hitting anything, that's a really good indication they're not really all that packed together. Yeah.
So, is the asteroid, could you go over the asteroid?
Yeah, you could.
Kind of like a...
Is it like a sphere? That's a good question.
Right, like
No.
go all the way. You know what?
Yeah, I know exactly what you're saying. You could go over the top of it, because the asteroid belt is pretty much in line with the plane of our solar system. So yeah, if you went from Earth and instead of going this way, maybe you went this way and then went around out here. Yeah,
Right.
you could go over the top
So
of it.
it doesn't cover it like a ball?
That's correct. Yep. Can asteroids hit Earth? What do you think?
Yeah.
Yeah. If they did, where would it probably hit? Russia, probably. I don't have an example of that, but if it would hit Earth, that's probably where it would go. Artists like to represent what it might look like if an asteroid hit the Earth. Examples like this. Yeah, the waves would be enormous. Yeah, something that big hits the Earth, we're all dead. So the question is, what about these asteroids that are actually near the Earth? Asteroids that might actually one day be in our orbit. So go ahead and write down near-Earth asteroids. Do that part and that part. So if you're looking on this picture here, the Earth's orbit is represented in this magenta-ish color here. And so if Earth is here, one type of asteroid that we don't have to worry about are these green ones, because the orbit of these asteroids never intersects with our own. So that's a more. We don't have to worry about those types of asteroids. There are two others that could possibly intersect with us, though, and that's the red and the blue. So that's Apollo and that's Aten. So these are the two that might pose a problem. Now, these don't all orbit exactly in line with our orbit disk. So it's not like this is in the exact spot where Earth is. You know, they could be in this location, and the asteroids might be a bit above or below us. So it's not like the threat is completely immediate there. But it is very important that we keep track and close, accurate results of where these asteroids are and where they're going to be headed. And thankfully, we've got lots and lots of real good computers and mathematical models that can warn us if something like that were about to happen. The real question comes in is, what about the asteroids that we don't have documented in our computers? Those are the ones we really got to watch out for. So yeah, Aten and Apollo, we got to keep an eye on, but Amor, we don't have to think about those too much. So, it's funny, we were just talking about Batman before class.
So do you think if, like we knew we were going to hit one, we like, I don't know, shoot it out on space or something?
That is a really, really good question, and I'm not going to answer it now because I'm going to have you guys answer it tomorrow or the next day. Because I want to know what you guys would do if the Earth was about to get hit with an asteroid. If you were on the committee of how to stop destruction and extinction from Earth, what would you do to solve that? So, we'll talk about that tomorrow or the next day. For this slide, write down the first bullet point.
What's the title?
For this slide, probably Why So Serious? I don't know. I didn't really give it a title. It's just general stuff for
You
asteroids.
said which one?
The first bullet point. And so when you see it needs to be 30 feet across, that's not how big it needs to be upon impact. That's how big it needs to be at the beginning, before it starts falling through our atmosphere and disintegrating. If you have something that starts 30 feet across, it's going to make it all the way through and cause a fair amount of damage when it hits. If you get up to 45 feet across, the damage would be 5 times greater than an atomic bomb. And that's the initial blast of the atomic bomb. You're not going to get radiation and stuff. But it gives you an idea of how quickly the damage goes up as these asteroids get bigger and bigger. Just a 15-foot difference in starting size gets you a lot more damage. So it's kind of interesting, and this is on your handout, gives you some sizes of some of our near misses here. So you can see in 1989 we were 430,000 miles away from this one, which was 1,000 feet across. And again, 5 times an atomic bomb would just be 45 feet across. So this would cause an insane amount of damage. In terms of asteroids that have gotten much closer than that, but not quite as big, you got some more down here. This one came within 26,500 miles of our orbit. This one, 12,000 miles, only 50 feet across for that one. In 2011, we came within 200,000 miles of this beast, 1,300 feet across. And again, 1,300 feet, that's about a quarter of a mile or so across. So that's a pretty big asteroid. If you would take, your 400 meter run and you extended it out in a straight line, that's how big this would be about. So, yeah. The real question, though, is how close were we really? Because, we're going really fast in our orbit as we go around the sun. Let me tell you, 430,000 miles seems like a long ways away, but it's really not. So that one that came by in 1989, they called it, I don't know how to pronounce that, Asclepius. 1,000 feet across. It came within 430,000 miles of Earth. And remember, Earth is moving very quickly in its orbit. That asteroid passed through the exact point where the Earth was in its orbit just 6 hours earlier. So that's how close we've come. Yeah. Something that size hits Earth, it would not be a happy day. Might look something like this. And this is the sort of thing where it's one of those things that it doesn't pay to worry about. It's one of those things where we're going to do our best with math and we're going to do our best with telescopes, finding as many asteroids as we can and documenting them. But it's one of those things that it's like, you got to give this one to God because He knows everything that we don't know, and He's kept us safe up to this point, and we rely on Him and His safety. But again, as our technology improves, we're going to be able to spot these earlier and earlier. What would happen if an asteroid hit Earth? Judging from realistic simulations involving a sledgehammer and a common laboratory frog, we can assume it would be pretty bad. Poor frog, I know. I like frogs. So, I'll tell you, I don't know, actually. But I do know, if this was me on the moon looking back at the Earth, I would look back at the Earth and I would just say, well, no, that's just super. Your reaction would probably be a little bit different. But, yeah. Hopefully that's not something that you see if you're one of the folks they send to the moon in 2024. Now, like I said, we're not going to discuss right here and now the best ways to handle asteroids that we know might be heading towards Earth. But what I will show you is what happens if an asteroid as big as Ceres were to hit the Earth. Would you like to see that?
Yeah, of course.
Okay. Yes, we're done with notes. Those of you at home, I'm sorry, but I'm going to be showing a video from YouTube, and if I leave it in this video, it would probably get blocked when I post it. So I'm sorry, but this video ends right here.